Hi guys. Okay, so it's actually Sunday right now. I'm making this review video for you guys for chapter 8. So this is review for chapter 8. Okay, I'm gonna do 9.1 next week. The whole chapter 9 is gonna be next week. So I'm just gonna review chapter 8 today. Okay. And okay, so it's Sunday, so I haven't graded your exam yet. So your grade will be ready sometime this week, okay? So I'll let you know when the grade is ready. What else? So if you haven't done chapter 8, please do it as soon as possible. It has 2 sections. And also 9.1 is also something you need to do this week as well. So the homework for 8.1, 8.2, and 9.1 are due Friday. When is that? So Friday, let's see, November 6th. Okay, so please let me know if you have any questions on 8.12 and 9.1. Now, for 8.1 and 8.2, I actually made a couple of videos for each section on homework questions. So when you go to the module for 8.1 and 8.2, you'll see a page that titled 8.1 homework questions. I forgot which numbers I did, like 3 and 5, something like that. I forgot which questions I did. And then for 8.2, I think I did the same thing for, I think number 2 and 6, I forgot exactly which numbers I did. But hopefully these 4 videos will help you do finish the homework. Okay, and if you have more questions on 8.1 and 8.2 homework, again, let me know. I'm more than happy to make videos for you or answer your questions in a discussion board. Okay, all right. So that's pretty much it for in terms of announcement. Okay, so let's move on to chapter 8 review. Okay, so chapter 8 is all about sampling distribution of a statistic. So the definition of sampling distribution, right? Sampling distribution of a statistic. So we've learned many statistics in chapters 1 through 3, right? So X bar, the sample mean, is one of them, right? Statistic is a value, value that comes from a sample, right? Statistic and sample go together. Okay, and also sample statistic, S. And also you learned this one, P hat, a sample proportion. Sample proportion is also a statistic, okay? And S squared, sample variance, right? So these are some examples of statistics, okay? So a sampling distribution of a statistic is a probability distribution for all possible values of the statistic computed from a sample size n. Okay, so 8.1 focuses on sampling distributions of means. Okay, means, so that'll be X bar. So we're gonna review that first. Okay, so it says here, for sample means, if a simple random sample of size n is drawn from a large population with mean mu and standard deviation sigma, then the sampling distribution of X bar, sample mean, okay, so this is sample mean, okay, And we'll have mean of x sub x bar equals mu, and the standard deviation sigma sub x bar equals sigma over square root of n, which is called the standard error of the mean. Okay, so here's an example, right? So let's say we have a population. Okay, how about students at West Los Angeles College, right? So that's going to be our population. Okay, so let's say we're interested in, so this is the population. And let's say we're interested in figuring out the average amount of time students spend on social media every day, right? So we're interested in, time spent on social media, okay, every day, right? So of course we're not going to be able to ask every single person at the college. It's going to take a tremendous amount of time. So what I'm going to do is I'm going to select a sample. Let's say I'm going to ask 40 people. That's doable, okay? But make sure I want my sample to be a random sample, right? So make sure I use a random sample, not just like, oh, I know 40 students at West LA, so let's interview them. That would not be a good idea. Okay, so yeah, random sample of 40 people, let's say, okay? All right, and then I asked each one how much they spend on social media every day. And maybe first person says, let's do by minutes, right? So 40 minutes. Maybe second person say 2 hours, so it's gonna be 120 minutes, okay? So, all right, so I asked all 40 people, and then I found the average, okay? Average, so that's gonna be X bar, sample mean, right? Sample mean. So I'm gonna add all the numbers, times, right, that are spent on social media by 40 people, and then divide the total by 40. So we get the sample mean. And let's say it happens to be 80 minutes, right? So that's the average amount of time these 40 people spend on social media every day, right? Okay, but this is just one sample, right? So this X bar 80 minutes is just the average of this sample, right? Only. Okay, so what I'm gonna do is I'm gonna keep continuing sampling 40 people. So again, I have a sample of 40 people, and then I'm gonna find the sample mean of that, for this group, right? So let's say I happen to get 100 minutes for this group, right? And let's keep going. So I have, again, a group of 40 people, and then I ask them, each one, how much they spend on social media, and X bar, the mean, happens to be, let's say, 112 minutes, right? And so you keep doing that. You keep collecting a bunch of samples, okay, bunch of samples, and then you calculate X bar for each sample, okay? Then after you find a bunch of X bars, right? So you're gonna end up getting many different numbers, values of X bars, correct? Okay, because you have different samples every single time. Then what we are now interested in is to see how these X bars, when you collect these X bars, how these guys behave, right? We want to know how these X bars will behave. So we want to know how X bars will behave. So what we're going to do is to make a distribution. We're going to put these X bars on a number scale so that we can see the shape of the distribution of X bars, right? So make a distribution of X bars, right? So that's what it is. This distribution of X bars is called the sampling distribution of sample mean. So this is called sampling distribution of sample means, which is X bar, right? So again, you start with the population, you get a bunch of samples, right? And then you calculate X bar, the sample mean for each sample, and then you make a distribution out of them, right? So, okay, we make a distribution. So what we're interested in is the shape, right? The distribution. So what kind of shape does the sampling distribution of means has, right? So let's take a look at case 1 here. So if our sample is a simple random sample, that's very important, okay? And if the sample is independent, or the sample size is less than 5% of the entire population, which is population size, n, okay? And then if the population is normally distributed, if you know that the population you're dealing with and has a normal distribution, okay, if these 3 things are satisfied, then you can safely conclude that the distribution of the sample mean is approximately normal. Okay, so case 1 says if your sample is a simple random sample and if the sample is independent, so n is less than 5% of the entire population size, and then also if you know that the population is normally distributed. Normally distributed is better. Is normally distributed. Okay, all right. So for this example of time spent on social media, let's say we know that the time spent on social media for West LAC students are normally distributed. Let's say we know, okay? Usually we don't, but let's say we know that it is normally distributed. Population is normal. Okay, if we know this, then this distribution of X bars, so after you collect a bunch of X bars and then you make a distribution of X bars, that sampling distribution of sample means is going to be approximately normal as well. So if the population is normal, then the distribution of sample means is also approximately normal. We can safely conclude that, right? And of course, you have to check these 3 requirements, okay? Right, so that's case 1, okay? Now, case 2 is actually more realistic because we usually don't know if the population is normally distributed or not, right? Because we don't know much about population, okay? So case 2 says if, okay, number 1 and number 2 requirements are the same. If your sample is a simple random sample, and if your sample is independent, so n is less than 0.05 times population size, okay? And if, number 3, requirement 3 says, if your sample size is greater than 30, right? So each sample, you see right here, I collect a bunch of samples, right? And then we found X bar for each sample. If each sample size is more than 30, greater than 30, then we can safely assume that the distribution of the sample mean is, again, approximately normal. Right? So let's say we don't know what population looks like, right? It doesn't say in the problem, or it's not established that the population is normal. You have no idea what the shape of the distribution is for the population, right? Okay, but as long as the sample size is more than 30, even though the population might not be normally distributed, we can conclude that the distribution of the sample mean is, again, approximately normal, right? Now, this has a special name called the central limit theorem, right? So that's case 2. Okay, it says the shape of the distribution of the sample mean x bar, right? So when you make a distribution of x bars, it becomes approximately normal as the sample size n increases regardless of the shape of the population. Okay, remember I said it doesn't matter if the population is not normal or normal, doesn't matter. As long as n is more than 30, then we can say that the sampling distribution is approximately normal. So the rule here says if n is greater than 30, so that's what I says here, n is greater than 30, then we can assume that the distribution of sample mean will be approximately normal. Okay, all right, so you're gonna have one of these two cases when you're doing examples, right? And another thing I want you guys to review here, make a note, and you will need this on your note card, right, for the next exam, is this one right here. So the distribution of the sample mean, okay, is approximately normal, and the mean of the sampling distribution, so this is sampling distribution of x bars, okay? So the mean of the distributions is mu, which is the same as the population mean, and the standard deviation of the sampling distribution is sigma over square root of n. Okay, so I want you to kind of imagine this distribution has a bunch of x bars in it, right? Because it's a distribution of x bars, right? So a bunch of x bars in there, okay? And when you add all these x bars and then divide by the number of x bars, then you get mu. And the standard deviation of this distribution is sigma over square root of n. Now keep in mind that the population, okay, population has mu, okay, that's the mean. Population has a mean of mu, and then standard deviation of sigma. So if you're taking a bunch of samples, right, from a population with a mean of mu and standard deviation sigma, okay, so you take a bunch of samples, and then you calculate x bar for each sample, right? And then you make a distribution of these x bars. Then the mean of those x bars is going to be same as the population mean, and the standard deviation is going to be sigma over square root of n. Okay, all right, so that's the review for 8.1. Now let's do one example. Okay, so this is actually example 1. Sorry, it says example 2. Okay, let X be a random variable standing for the incubation time for the eggs of Allen's hummingbirds. We don't know whether X is normally distributed. Okay, this is important, right? We don't know whether X is normally distributed. Okay, but it has mu equals 16 days and sigma equals 2 days. Okay, so we know that we have a population with a mu of 16 and sigma of 2, but what we don't know is if the population is going to look like a normal or something different, right? Okay, keep reading. We have n equals 49 eggs in an incubator. Let X bar be the mean incubation time for these eggs. Okay, sorry, this is supposed to be A and B. All right, describe the sampling distribution of the sample mean incubation time, shape, mean, and standard deviation. Okay, so let's visualize really quick. Okay, if you can just write the answer right away, that's fine. But I'm gonna visualize it so that we know what we're talking about here. All right, so we have a population. Okay. We know that the mu is 16, the mean, right? The population mean incubation time is 16 days, and sigma is 2. Okay. So we don't know how the distribution looks like, right? Okay, but that's the information we have. Okay, then we're going to take a sample of how many? 49 eggs. Okay, 49 eggs. And then X bar represents the mean incubation time for these 49 eggs. So we take these 49 eggs and we calculate the average incubation time for these 49 eggs. Whatever that might be, we don't know, but let's say X bar represents that, right? The mean incubation time. Okay, right? Maybe 15, maybe 14, we don't know, all right? It could be any number, okay? Depending on the sample, right? Now, let's take another sample, okay? Because they're talking about sampling distribution sample mean incubation time. Okay, and then you calculate the mean incubation time for that sample. And so you keep doing that, right? You keep selecting the same amount of eggs and then calculate X bar for that sample, and same thing many times, many times. So you're gonna end up getting a bunch of X bars. Okay, so let's call this one X1 bar, X1 bar, X2 bar, X3 bar, 4, 5, 6, 7, 8, and it keeps going. Okay, all right. Now the question is, when you make a distribution of these X bars, okay, when you make a distribution out of sample means, so these X bars, how does it look like? What is the shape of the distribution? Well, we learned in the previous page that if, well, actually we have to kind of go through the 3 requirements, right? But which case is more appropriate here? Case 1 or case 2? Well, case 1 is where the population is normally distributed, right? Well, it doesn't say that. It says we don't know whether X is normally distributed. So case 1 would not work, right? Okay, so we're gonna have to go with case 2. Okay, so case 2 says, okay, is our sample simple random sample? Ooh, it doesn't say it. It should. Okay, let's pretend that this one is a random sample. Oh, Mrs. Forbes, you cannot do that. Okay, well, we're gonna assume, okay, that they did their homework and they did a they used simple random sampling, right? So yes, go right ahead. I'll make sure that I put random sample when you take an exam. Okay, so simple random sample, check. Okay, number 2, is n less than 0.05 times the population n, right? So n is 49, okay? Is 49 less than 5% of the entire population? Now, it's a little bit hard to tell because we don't know the population size, right, for this one, okay? So, but let's see here. If you divide 49 by 0.05 to isolate n, right? So 49 divided by 0.05, that's 980. So if the population size is more than 980, we're good to go, okay? Now again, we can really tell if that is true or not, but let's assume that it is, okay? So we can actually move on, okay? Of course, when you're doing this research, actually doing the research, you're gonna have to really figure it out. You know, you have to verify this requirement, but for now, let's assume that he has more than 980. Okay. All right, so number 3. So it's case 2. So it's gonna be sample size. It's sample size more than 30. Okay, this one you really have to verify, right? So yeah, it is. Look, n is 49, which is more than 30. So great, since n is more than 30, this checks as well. Okay, so what this tells us, let's just come over here, is that so the shape, okay, of the distribution is approximately normal. Okay, because these 3 things are satisfied. Okay, and then another thing they want you to find is the mean. So that's mu sub x bar. So remember the formula, the mu sub x bar is the same as mu, so that's 16. This guy. Okay, and finally, standard deviation. That's sigma sub x bar. They're talking about the standard deviation of the sampling distribution. Okay, so it's going to be sigma sub x bar. So that's sigma over square root of n. So that will be 2, that's sigma right here, over square root of 49. Okay, which is 2 over 7. All right, okay, so part B. What is the probability that a random sample of 49 eggs has a mean incubation time of less than 15 days? Okay, so now we're talking about the probability of the mean incubation time, which is x bars, right? And how do we know it's the x bar? Because we're talking about a random sample of 49 eggs, right? So we're talking about the sample mean, not mu. So we're talking about the sampling distribution of sample means. Okay, so we have a bunch of x bars in this distribution, and each x bar represents the average incubation time of 49 eggs. Average or mean incubation time of 49 eggs. Okay, but you have different samples, that's why you have a different means, right? And the mu sub x bar is, so the average is about 16 days, and the standard deviation is 2 over 7. That's what we found up here. Okay, all right, so what they're asking us is what is the probability, right? So remember, the probability equals the area, okay, for the continuous probability distribution. Okay, that the mean time is less than 15 days. Okay, so 16 is in the middle, so 15 is like here. So let me just put 15, maybe like right here. Okay, 15 days, less than 15 days. So it's gonna be the left side. Okay, so basically they're asking you to find this area. All right, so we know, okay, so the probability of less than 15 days. So we know that this is approximately normal, so we can use normal CDF function to find the area, right? Okay, so I'm going to be using the calculator function normal CDF, and then we have to figure it out. Lower, upper, mu sub x bar, sigma sub x bar. Okay, so the lower will be negative 1e99 because the left side is shaded, and the upper will be 15, and mu sub x bar, that's these two guys right here, and sigma sub x bar, that's 2/7. So it's a pretty small number, so that's 0.0002. Okay, so this is 8.1 review. So again, in chapter 8 module, right, I made 2 more videos for chapter 8.1 homework questions. So take a look at that. Okay, and hopefully that will help you do homework. And if you need more help on other homework questions, that's so absolutely fine. So post your questions in a discussion board, or just email me and ask me for more videos so that I can help you with that. Okay, cool. So let's move on to 8.2. So in 8.1, we learned sampling distribution of sample means. Now in 8.2, we are going to be looking at sampling distributions of proportions. Okay, so when we talked about the binomial distribution in chapter 6, okay, your favorite, right? We were interested in the number of successes, which is x, out of n trials. Remember, we have n fixed trials, right? And independent trials, and then we have X amount of successes, right? Okay. Now we're interested in the proportion of successes in a sample of n trials, right? And then we use this notation p hat for a sample proportion, which is given by p hat equals x divided by n, right? We divide the number of successes by the total. Okay, so this is actually very important, right, to write on your note card, right, or memorize it. Okay, now you might be wondering like why we need to know about p hat here. Like we were always given the value of p, which is the probability of success in chapter, it says chapter 5, but it has to be chapter 6 here, right? We were given the probability of success. But when we are doing inferential statistics, which is coming up in the next chapter, right, we will need to use a sample proportion, which is p hat, to estimate an unknown population proportion p. So p is actually unknown, right? And we're trying to estimate what the value of p is using the sample proportion, which is p hat. So that's what you need to know about the p hat, right? Okay, so what do we know about the sampling distribution for sample proportions? Okay, so there are 3 things I want you guys to know, right? You need to write these on your note card, right? The mean of the sampling distribution of p hat is mu sub p hat, which is p, the population proportion. And the standard deviation of the sampling distribution p hat is sigma sub p hat, which is the square root of p times 1 minus p over n. Okay, and then finally, requirement 3, if n times p times 1 minus p is greater than or equal to 10, then the sampling distribution for sample proportions is approximately normal. okay? I don't know if you guys remember this one, but the standard deviation for binomial distribution, that was a square root of n times p times 1 minus p. So actually, n times p times 1 minus p is the variance of binomial distribution. So if the variance is greater than or equal to 10, then we can safely assume that the sampling distribution of sample proportions is approximately normal. Okay, so let's visualize this one, right? So let's say you have a population. Okay, so you start with a population. Okay, how about people in California? Us, right? Okay, so that's our population, big population, okay? And let's say what we're interested in now is the proportion of vegetarians in California. Let's say we're interested in that, right? So that's gonna be the actual P, right? The population proportion of vegetarians in California, right? Well, that's gonna be really hard to get because in order to find P, okay, you need to ask every single person in California whether they're vegetarian or not, and then you have to figure out the proportion that way, right? But nobody has time and resource to actually ask every single person to get the actual proportion of vegetarians in California. So p hat is really hard to get, right? That's why it's usually unknown. All right. Okay, so we were interested in, oh, sorry, did I say p hat? Or it's really hard to get p, right? So that's why you need to find p hat. P hat is a sample proportion, so it's much more manageable, right? Okay, so what we're gonna do is we're gonna take a sample of, let's say, 100 people. All right, we're gonna take a sample of 100 people. Okay, that's not too bad, right? Random sample, of course, right? Random sample of 100 people. Okay, and then you're gonna ask each person if they are a vegetarian or not. And then let's say I'm just making this up, okay? But let's say 5 people said they are. All right, so in terms of proportion, which is p hat, which is given by x over n, right? So 5 people say they are vegetarian out of 100 people we asked. So that's 0.05 or 5%. Okay, so 5% of our sample of 100 people is a vegetarian, right? Okay, so that's our p hat. P hat is a proportion, so it's 0.05 or 5%. Okay, but again, this is just one sample, right? So let's say you have another sample of 100 people. Okay, and then you ask every single person if they're vegetarian or not, and then, okay, and you found out from this group there are actually 7 people who are vegetarian. So you go, oh, okay, so for this group, p hat is 7 over 100, which is 0.07 or 7%. Okay, so let's say we have a bunch of samples of a size n equals 100. Okay, and then you calculate p hat for every single sample. So let's say this one p hat was 0.15. Maybe for this one p hat was 0.10. Maybe this one p hat is 0.05 again, and all that, right? So you're gonna collect a bunch of samples, and then you calculate p hat for each one, and then you're gonna end up getting a bunch of p hats, right? So you have p hats here, p hats here, p hats, p hats here, p hats, p hats, p hats, p hats, p hats, right? Okay, all right. So then you're gonna make a distribution. You're gonna make a distribution of these p hats. Okay, so you make a distribution of these p hats. What kind of a shape does it have? Well, there are 3 requirements. And if these 3 requirements are satisfied, then we can conclude, just like we did in the last example, in the last section, that the sampling distribution of proportions is approximately normal. Okay, so these requirements are SRS, okay, so the sample is simple random sample, okay, that's not new to us. And then number 2, the sample is independent, so n is less than 0.05 of the entire population. Okay, and then number 3 is this one right here. N times p times 1 minus p is greater than or equal to 10. So if these 3 items are satisfied, then you can conclude that the distribution of p hats. See, now we have a bunch of p hats in the distribution. When you collect all the p hats, right? When you collect all the p hats and you put them on a number line, and then they're gonna form they're gonna look like a normal distribution. So mu sub p hat of this distribution is p, the population proportion. And the sigma sub p hat, which is the standard deviation of the distribution, is the square root of p times 1 minus p over n. Okay, so that's a quick review of 8.2, right? And now we're going to be using this concept to do the example on the next page. Okay, example 2. According to the U.S. Census Bureau's American Community Survey, 87% of Americans over the age of 25 have earned a high school diploma. Suppose we are going to take a random sample of 200 Americans in this age group and calculate what proportion of the sample has a high school diploma. Okay, describe the sampling distribution of p hat, the sample proportion of Americans over the age of 25 who have earned a high school diploma. Shape, mean, and standard deviation. Be sure to verify the model requirements. Okay, so since they are talking about the sampling distribution p hat, let's understand what's happening here, right? So we have a population, okay, and then we take a bunch of samples. Okay, we don't know how many, but just take a bunch of samples. So just sample, 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 you know. Okay, then you find the sample proportion p hat for each sample. So p1 hat, p2 hat, p3 hat, and so on, right? Okay, so each p hat represents the sample proportion of Americans over the age of 25 who have earned a high school diploma. Okay, and then you make a distribution of these p hats. Okay, so what is the shape of the distribution? Okay, so we're gonna check these 3 requirements, right? SRS, yes, it says random sample, so we're good to go. Okay, and is n less than 5% of the population? Okay, so what's n here? So n, we have 200. Okay, we take a sample of 200 Americans, so 200 is less than 0.05 times big N. So let's divide 200 by 0.05. So that's 4,000, right? So do we have more than 4,000 Americans over the age of 25? Yes, absolutely. Okay, we don't know the exact number for this population, but we know we can easily assume that it's more than 4,000. Okay, so yes. Okay, number 3, n times p times 1 minus p. Is this greater than or equal to 10? Okay, so p, that's the population proportion. So that's here, right here. According to the U.S. Census Bureau's American Community Survey, 87% of Americans over the age of 25 have earned a high school diploma. So that's P right here, population proportion. So N will be 200. So 200 times 0.87 times 1 minus 0.87. Is this greater than or equal to 10? Okay, so it's 200 times 0.87 times 1 minus 0.87. So that's 22.62. So yes. Okay, so these 3 requirements are satisfied. What does it mean? It means shape of the sampling distribution is approximately normal. Not the population. Okay, we don't know what the population looks like, but the sampling distribution shape. Okay, if you collect all p hats and you make a distribution, the distribution of sample proportions is approximately normal. Okay, now mu sub p hat, that's same as p. So p is 0.87. Okay, all right, and then sigma sub p hat, that's the square root of 0.87 times 1 minus 0.87 divided by 200. Okay. Okay, all right, so you can go ahead and punch these numbers in your calculator. Okay, so it's about 0.0278. Okay, now you're going to be using mu sub p hat and sigma sub p hat in part B, right? So for mu sub p hat, you can go ahead and use 0.87. Okay, for sigma sub p hat, I would like to use this exact form. Not the estimated version. I want to use this exact form when we were using normal CDF or inverse norm, okay, so that we can get more accurate answer. But if you would like to use the decimal version, which is 0.0278, that's okay too. But be careful when you're doing homework; they might ask for a specific number of decimal digits. Okay, so pay attention to that instruction. Okay, all right, so part B. What is the probability that the proportion of people in the sample with a high school diploma is less than 85%? Okay, so it is really clear that we're talking about the sample proportion here, okay, proportion of people in the sample, right? Okay, so we already know that it's normal. Okay, all right, and then we know that we have a bunch of p hats in this distribution. Okay, these p hats are here. Bunch of p hats. Some p hats are small, some p hats are large, Some p hats are right in the middle. Okay, good. And then we know that the mu, which is the middle, okay, the center is 0.87, and sigma sub p hat is about 0.0278. All right. So let's see. So we want to find the probability that the proportion of people in the sample with high school diploma is less than 85%. So 0.87 is here. So 85%. So somewhere here, 0.85 less than that. Okay. So probability that the sample proportion, okay, proportion in the sample, that's p hat, is less than 0.85 equals, okay, equals, this will be normal CDF, okay, and lower upper mu sigma, or mu sub p hat, sorry, and then sigma sub p hat. So lower will be negative 1e99, upper will be 0.85, mu will be 0.87, and then sigma, and you can use this one or the whole thing. I'm gonna use the whole thing. 0.87 times 1 minus 0.87 divided by 200. Yeah, type the whole thing in your calculator, right? Okay. So let me grab my calculator. It's normal CDF. Negative 1e99, 0.85, 0.87, and the square root of 0.87 times 1 minus 0.87 divided by 200. Okay. All right, so I got 0.2001 or 0.200. Okay, so the probability that the proportion of people in the sample with a high school diploma is less than 85% is about 0.2, okay, or 20%. Okay, so that's it for section 8.2 review. And again, if you go to not week 8, was it week 9? Chapter 8 week module, right? You're gonna see 2 additional videos for homework questions, okay? That I made homework question videos. I think it was number 2 or number 6. I forgot which numbers I made videos on. So watch them, okay? Hopefully that will help you do complete your homework. But again, if you have more questions on other problems, let me know, okay? All right, okay, that's it. Have a good night or have a good day. I don't know when you are going to be watching this video. And then I will see you next Tuesday, which is what? Well, today's Sunday, but this is supposed to be for Tuesday, November 3rd, right? So I'll see you on November 10th, okay? So that's going to be the next review session day. Okay, guys, bye.